video we are going to discuss about Perkin reaction. It is one of the important name reaction. Now let's study about this Perkin reaction and its mechanism. See here, first let's see the definition. In Perkin reaction, the condensation has been effected between aromatic aldehydes and aliphatic acid anhydrides in the presence of sodium or potassium salt of the acid corresponding to the anhydride to yield alpha beta unsaturated aromatic acids. Now I will simplify the definition. Here in the Perkin reaction what happens means condensation has been effected between aromatic aldehydes and aliphatic acid anhydrides. See here, condensation occurs between aromatic aldehydes like benzaldehydes and aliphatic acid anhydrides. So in the place of aliphatic acid anhydride, we are taking the example of acetic anhydride. See here, benzaldehyde and acetic anhydride, that too in the presence of sodium or potassium salt of the acid corresponding to the anhydride. Here anhydride we have taken, that is acetic anhydride. So the sodium or potassium salt is sodium acetate or potassium acetate, which yields alpha beta unsaturated aromatic acids. So here the famous example is this one. It is a preparation of cinnamic acid. See here, here is a carbonyl group. Beside this carbonyl group, this position is called as alpha position and this position is called as beta position. In the alpha and beta position there is a unsaturation. See here, there is a unsaturation, so it is called as alpha beta unsaturated aromatic acids. So when the benzaldehyde reacts with the acetic anhydride in the presence of sodium acetate or potassium acetate, will give us alpha beta unsaturated aromatic acids, that is cinnamic acid and acetic acid. This is the very important example. And you have to remember that the acid anhydride which we have taken should contain at least 2 alpha hydrogen. See here, here is acetic anhydride, here is a carbonyl group. Beside this first position is called as alpha position, so here is a alpha hydrogen, and here is also a carbonyl group. Beside this also is having a alpha position, here also having a hydrogen atoms, so it is also alpha position. As I have already said, the acid anhydride should have at least 2 alpha hydrogen. So here is a 1 alpha hydrogen, here is a second alpha hydrogen. So there are 2 alpha hydrogen in this acid anhydride. So now let's see the mechanism of this Perkin reaction. Here the mechanism is very interesting. It completes in 6 steps. See here, here the first step is formation of acetate ion. So how this acetate ion is formed means by breaking down of the salt of CH3COONe. This salt will break down and we will get an acetate ion. So this CH3COONa, that is sodium acetate, will become CH3COO minus plus Na plus. So here we have got acetate ion. Now the formation of acetate ion is completed. Next, the formation of carbon anion. How this carbon anion is formed means, here is a acetate ion, here is aliphatic acid anhydride, that is acetic anhydride we have taken. This acetate ion will abstract a proton from this aliphatic acid anhydride. So here this will abstract a proton from this aliphatic acid anhydride and this bond is shifted towards carbon. So there is a formation of acetic acid. Why? Because this acetate ion will abstract a proton, then it will become CH3COOH. Plus what is remaining here? Here is CH2COOCH3. Here this bond is shifted towards carbon, so this carbon will get a negative charge. Here this is the carbon anion. What is carbon anion? It is an anion in which carbon is trivalent. That means it is having 3 bonds and a negative charge. So here is the carbon anion. Next, third step is attack of carbon anion on carbonyl carbon of benzaldehyde. We know that we have taken benzaldehyde and it consists of carbonyl carbon. So here is a carbon anion which will attack the carbonyl carbon of benzaldehyde. This double bond is shifted towards this oxygen, that is one of the bond is shifted towards oxygen. Then this carbon will get a partial positive charge, so it will be get attacked by the carbon anion. Then the formation of alkoxide ion takes place. Now let's write the product here. So here is a benzene ring. For this, here is a CO minus. Why? Because this bond is shifted towards oxygen, so oxygen will get a negative charge, and here is the hydrogen. I will write it here and I will attach the whole part here. So here is a CH2, CO, CO, CH3. It is the alkoxide ion. Alkoxide ion general formula is RO minus. Here for the negative oxygen, if a organic group is attached means then it is called as alkoxide ion. Here what happened? Here the attack of carbon anion on the carbonyl carbon of benzaldehyde has taken place and the alkoxide ion is generated. So in the next step what happens means the alkoxide ion abstract the proton from the acetic acid. So here this acetic acid consists of a proton. So this proton is abstracted from the alkoxide ion which is formed above. So here this alkoxide ion will abstract a proton of this acetic acid. So the product will become here OH and everything remains the same. And next step is dehydration. Here dehydration means from the alpha position, here it is the alpha position, here is a carbonyl carbon. Beside this the first position is called as alpha position and the second position is called as beta position. From the alpha position remove one of the hydrogen atom and from the beta position remove the OH. Then see here from the alpha position I have removed an hydrogen, so it will become CH. Here is a CH2 and here is CH. From the beta position I have removed OH, so here is only CH, 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 OH is removed. So the dehydration is carried out like this. So the final step is hydrolysis for the above product formed. What is hydrolysis? By using water we are breaking down the compound into two parts. So let's break the product here. Here H and here is OH. This is hydrolysis. I have used water and I have made the compound into two parts. So here let's write the product. So here is a benzene ring. For this here is CH and double bond CH, CO and here is OH. This is one product and another product is here is CO and here is OH, CH3. So as you can see it is CH3COOH, that is acetic acid and it is cinnamic acid. Here you can see it is the alpha position and it is the beta position. Alpha beta unsaturated acids or yielded. This is about the mechanism of Perkin's reaction. If you have any doubt, please ask them in the comment section. And I have mentioned a point here, that is prolonged heating, that is about 5 hours, and high temperature is required since a weak base has to react with weak acid. Here I have mentioned the temperature, that is 170 to 180 degrees Celsius, and the temperature is 5 hours. Why? Because here the weak acid should react with the weak base. Here weak acid is anhydride and the weak base is acetate ion. That's why this temperature and this prolonged heating should be taken place. Here I have taken some examples for this Perkin reaction. See here. Here is a reactant. That means these are aromatic aldehydes, and when they are heated with acid anhydrides, that is aliphatic acid anhydrides, in the presence of sodium acetate or potassium acetate, we will get alpha beta unsaturated acids. So from these three things we came to know that it is of Perkin's reaction. So we can directly write the product. Now I will tell you the trick to directly write the product here. So in the position of this CHO, in the position of this aldehyde, that is CHO, we have to write CH double bond CH single bond CO OH. That's it. This is a simple trick. Second example also we can see here. Here is a CHO. In the CHO position, by seeing this aliphatic acid anhydride and by this sodium acetate, we came to know that it is a Perkin reaction. So in the position of CHO, directly write CH double bond CH single bond COOH. That's it. This is all about Perkin reaction. Thank you for watching.